Hello viewers, in today's class we are going to discuss one important problem from probability distribution, right? So here we'll find the probability distribution of a random variable, and we'll also find the mean and variance of the probability distribution or the random variable, right? So here we have a problem which goes like this. A bag contains one red and three white balls, right? And we have to find the probability distribution of the number of red balls, right? So we have to find the probability distribution of the number of red balls if two balls are drawn at random from the bag one by one without replacement, right? So here what we will do, we'll take the random variable as x, right? So let x be the random variable. Now for more details you can watch my earlier videos on probability distribution, right? And here x denotes the random variable which gives us the number of red balls, right? Which gives us the number of red balls when the random experiment of drawing two balls has taken place one by one without replacement. So now when we conduct the random experiment of drawing two balls from the bag one by one without replacement, then this random variable x, which denotes the number of red balls, then this x will take the values either 0 or 1, right? Why 0 or 1? Because it may happen that in the first draw which we call as draw number 1, in the first draw we may have both the white balls, right? So both the white balls, that is denoted by WW, it will correspond to x is equal to 0. It means there will be no red ball, right? And in the second instance, that is draw number 2, it may happen that either we have the first ball as white ball and the second ball as the red ball, right? Or we may have in the first draw we may have the red ball, or in the second draw we may have the white ball, right? So in both these cases we have one red ball. So these two events corresponds to x equal to 1. It means one red ball, right? So viewers, here we have denoted x as the random variable which denotes the number of red balls, right? So when we are drawing two balls randomly from the bag one by one without replacement, so x can take values either 0 or 1. Why 0? Because in the first draw we may have when we draw two balls one by one without replacement, then it may happen that in both the cases we may have both the white balls, right? So this is x equal to 0. It means no red ball is drawn. In the second case, that is draw number 2, either we may have the first ball as a white ball and the second ball as the red ball, or we may reverse the case, that is in the first draw we may have the red ball and in the second case we may have the white ball. So in both the cases we have one red ball, right? So both these cases corresponds to x is equal to 1. So now if we wish to express this information in the form of a diagram, then we may have two sets, right? And the random variable x is from set A to set B, where set A has the events, that is WW, WR and RW, which are the same events, right? So here we have the random variable 0, that is x takes the value 0, and here we have 1. So WW is mapped with x equal to 0, and WR or RW, that is these two events, are mapped with 1, right? Okay, so now this is the diagram of this random variable, uh, which is a function from set A to set B, right? And the domain of this x is these three events, right? And if we wish to write it as a function, then we can write x of WW is equal to 0, x of WR is 1, and x of RW is also 1, right? So the image of both these events is equal to 1, right? Okay, so now this is the situation, and now we have to find the probability distribution of this random variable x. So for this, what we will do, we'll prepare a table, and here we have in the first row we have the random variable x, and in the second row we have the probability of the random variable x, right? So here we have x is equal to 0, here we have x is equal to 1, right? So it means here we have p of 0 and here we have p of 1. So p of 0, it implies that there is no red ball, right? And p of 1 implies that there is only one red ball, right? So now we have to find these two probabilities. So when we have the probability of getting no red balls, it means we have to find p of WW, that is both the balls drawn are white balls. So we have PW times PW, that is the probability of drawing a white ball in the first draw is given by 3/4, and the probability of getting another white ball in the second draw, when in the first draw we have already obtained a white ball, so we have 2/3, right? Because here the number of white balls is reduced by 1 and the total number of balls are also reduced by 1. So now here 3 and 3 get cancelled and we have 1/2, right? Now p of 1, that is the probability of getting only one red ball, is given by these two events, right? So either we can have the first ball as white and the second ball as red, or we can have the first ball as red and the second ball as white, and we'll add both these probabilities, right? So p of WR, it implies that in the first draw we have to obtain the white ball, so we have 3/4, and now one white ball has been drawn. So now the number of red balls is 1/3, right? Because here the number of balls are reduced by 1. And in the second case, the probability of drawing the red ball in the first draw is given by 1/4, and now the probability of getting a white ball when red ball has already been drawn is given by 3 over 3, right? So now this is 3 and 3 get cancelled, so we have 1 over 4, and here 3 and 3 get cancelled, so we have 1 over 4. This is 2 over 4, that is 1 over 2, right? So now here this expression can also be written like this. So we have PW times P of R, then here we have P of R, and then P of W, right? So viewers, now the probability distribution table, it can be written as see, here we have x, here we have P of x, and here we have x equal to 0 and 1, and corresponding to x equal to 0, the probability, that is P of 0, is half, and the probability corresponding to x is equal to 1 is also half, right? So this is the required probability distribution for this random variable, right? Now let us find out the mean and variance of this probability distribution. So now viewers, the mean of this probability distribution is given by sigma of xi times P of xi, right? So this is the formula for obtaining the mean of this probability distribution. So here we have the values of x are 0 and 1, and P of x is half and half, right? So here we have x1 P x1 plus x2 P of x2, right? So x1 is 0, and the probability of that is x equal to 0 is given by half. So P x1 is half, x2 is 1, and P of x2 is half, right? So this is 0, this is half, so this is half, right? So the mean of this probability distribution is half. The mean is also known as the expectation value of x. So the expectation of this probability distribution or the random variable is denoted by E of x, and this is given by half, right? Now let us find out the variance of this random variable. Now viewers, the variance of the random variable x is given by the relation that is P of xi square minus sigma of P of xi and xi whole square, right? So this is the relation to use to find out the value of variance of x, right? So here sigma of pxi times xi square is given by 0 square, because x1 is 0 times, here we have 0 square and px1, and px1 is half, then we have 1 square, and px1 is half, right? So this is the value of this term, right? And here we have sigma of xi pxi, which we have just calculated, which is the mean, and this is given by half. So here we have simply half square, right? So now we can solve this. So this is 0, and here we have half, and this is 1 over 4, and this is 4, and 2 minus 1, that is 1 over 4, right? So the variance of this random variable is given by 1 over 4.